Okay, today we're moving on to Unit 7, Day 1, and we're talking about multiplying and dividing rationals. So as we are simplifying, we are going to be doing a lot of factoring. So in my numerator, I'm going to factor out a 3x and a negative 6. I can divide those both by 3. So I'll factor out the 3. 3x divided by 3 is 1x, or just x. Negative 6 divided by 3 is negative 2. Then in the denominator, I am going to factor this trinomial, so it's going to create two binomials. So I think what multiplies to negative 10 adds to 3. That would be 5 and negative 2. So x plus 5, x minus 2. If you like to do the AC method, you do 1 times negative 10 is negative 10. B at the bottom, which is 3. What multiplies to negative 10 adds to 3, 5 and negative 2. So same thing. All right, so we'll talk a little bit more further on down this unit where we have discontinuities here. But take a look, what can we simplify? Just like if I was simplifying the fraction 2 over 2, 2 divided by 2 is 1. So I have x minus 2 on top and x minus 2 on bottom. So those divide out and become 1. So they we can say cancel out. And what am I left with? I'm left with 3 over x plus 5. And that is fully simplified. So we have a domain restriction. We know that I can never have a fraction with 0 in the denominator because that would be an undefined number. So how would this denominator become 0? What would be in here for x? X could never be negative 5. So we'll end up having an asymptote with that later on when we're graphing. So just remember, denominator can never be 0. Put that in the back of your mind. We'll hold on to that later. Okay, the next one, the trinomial in the numerator. So I'm going to factor that out. I've got 21 at the top, 10 at the bottom. What multiplies 21? Adds 10, 7, and 3. So that's x plus 7, x plus 3. In the denominator, remember I have a difference, minus sign, of two things that are perfect squares. So what multiplies to negative 9 adds to 0. That's 3 and negative 3. Or I can split that up. So split up x squared into x and x. Split up 9 into 3 and 3. The only way I have no b term, no middle term, is if these are opposite signs. And take a look. I have an x plus 3 in the numerator and denominator. They divide out. So I'm left with x plus 7 in the numerator, x minus 3 in the denominator. I don't need parentheses any longer, so I can just write x plus 7 over x minus 3. Now notice, I cannot just cross out those x's because they're both x's. They're still part of a binomial with that plus sign there. So I cannot divide out if they're part of the binomial, meaning there's a plus or minus sign. Final answer. All right, so now we are going to, that was just simplifying, now we're going to multiply rationals. So when I'm multiplying, I'm always going to factor them both first. So I can still write two fraction bars. I could also just make one large one. Does not matter. So I'm just going to go piece by piece and start factoring. So first, 3x squared plus 6x. I can divide both of those by 3 and x. So 3x squared divided by 3x is 1x, or just x. 6x divided by 3x is 2. Now let's take x minus 4. Cannot be simplified, so I'll just write x minus 4. But I notice I've got a lot of parentheses. I will throw it in parentheses. You don't have to. All right, denominator, x squared minus 4x. Two terms, I'm thinking either a difference of squares or I'm thinking a GCF. The greatest common factor of x squared and 4x is x. So x squared divided by x is x. Negative 4x divided by x is negative 4. Nice, I'm seeing some stuff that can divide out. And my trinomial here, if you need, we got 14 and 9. Multiplies 14, adds 9, 7 and 2. X plus 7, x plus 2. Okay, what is in the numerator and denominator? X minus 4 and the x plus 2's. Okay. Additionally, I've got a 3x and an x. I can divide out the x's. They're not part of a binomial. There is no plus or minus there. So I can divide those. What is left in the numerator? Just 3. What is left in the denominator? X plus 7. Final answer. Okay. One thing I want you to note here is if this had said, what if it had said 4 minus x? And I'm needing it to eventually match this x minus 4. I could have divided out a negative 1 if I needed to. Now this is not the case, but what if, right? I could have divided out a negative 1, so this would be a negative 4 plus x, or flip the order, because it's addition, x minus 4, if I had to. So we're playing the what if game. All right, let's look at the next one. Okay, so I'm going to break this down into parts. X minus 3 cannot be broken down. 4x squared y cubed, that's 4 times x times y times y times y. Okay, in denominator, that's x times y times y. And a trinomial multiplies to negative 12, adds to 1, so x plus 4, x minus 3. All right, and what divides out? X minus 3 is for sure. Okay, now I have, and this is really this one big fraction bar, because multiplying fractions, I just go multiply everything on the top, everything on the bottom. All right, so I can cancel out 1x on top, 1 on bottom, 2 y's on top, 2 y's on bottom. And what is left? In the numerator, I'm left with 4 and x, so 4x. In the denominator, I'm just left with x plus 4. Ooh, I'm also left with a y in the numerator. We cannot cancel out these 4's. The 4 in the denominator is a part of a binomial with that plus sign. So this whole thing is my final answer. Let's look at some division. So first, recall, when we are dividing fractions, we have the keep, change, flip. So if I'm dividing these fractions, keep the first, change it to multiplication, flip the second, and then we multiply across the top. 2 times 3 is 6 over 5 times 7 is 35. So let's look at a rationals. Keep the first, so 7x over x minus 10. Change it to multiplication, flip the last. Then we factor. So now I'm just going to go ahead and factor both of these. So 7x can't be factored. X minus 10 can't be factored. Maybe write in parentheses if you need to see it. Okay, the numerator of the second fraction, trinomial, so I'm going to have 2 binomials. Multiplies to 30, adds to negative 11. That will be two negatives, negative 6 and negative 5. In the denominator, I've got x squared and a negative 6x. I can divide out an x. So I'm left with x minus 6 then. And what divides out? These x's can be divided out. Can divide out x minus 6. And let's see what's left. What is left is the 7 times x minus 5. And in the denominator, x minus 10. So the x minus 10 does not have to be in parentheses, but the x minus 5 must, because we have the 7 in front. So this would be an acceptable answer. Now, if we're simplifying, you could put the 7 back in and multiply it. So 7x minus 35 over x minus 10. Okay. All right, so this next one got a lot going on. We are multiplying, so now I've kind of mixed them up. We got multiplication and division. The numerator of that first fraction is messy. I have, let's see here, I've got 3 terms, but I have a power of 5. So let me think. Can I make this into a trinomial that has a power of 2? Can we take out some x's? We can take out x cubed. Can we also divide by a number? I'd love to have an a term of 1, so I can use my shortcut. Can they all be divided by 6? Yes. So 6x to the 5th divided by 6x cubed is just x squared. Negative 30x to the 4th divided by 6x to the 3rd is positive 5x. Negative 84x cubed divided by 6x cubed is negative 14. Try the denominator on your own. Pause the video. So I'm dividing out of 3x cubed. So I got x squared minus 10x plus 16. All right, my other fraction, I've got x minus 8. And the denominator, might as well factor that now. We got x plus 10, x minus 10. Nope, x plus 10, x plus 7. Multiplies to 70, adds to 17, 10, 7. All right, so my fraction on the left-hand side has trinomials that I can go ahead and continue to factor further. So let's go ahead and do that. So my fraction on the right that I'm multiplying, I cannot factor any further, so I'll just go ahead and rewrite those. And on the left-hand side, I'm going to get some further factoring. Multiplies to negative 14, adds to 5. That would be 7 and negative 2. So x plus 7, x minus 2. Multiplies to 16, adds to negative 10, x minus 8, x minus 2. And what divides out? I've got x minus 2's, x minus 8, x plus 7's, x cubes out front, okay, and 6 over 3 reduces to 2 over 1, so we'll reduce that. Okay, what is left in the numerator? Just 2. Denominator, I've got 1 times x plus 10, so just x plus 10. Final answer. All right, my recommendation now is for you to pause the video, try the next 2, and then press play on the video and check your work. Okay, I'm not gonna leave any pause time. I'm just gonna let you try on your own. Okay, hopefully you listened, and now you're ready. So I am going to do, this is division, right? We need to keep, flip, or keep, change, flip. Keep, change, flip. So I've got 4x over 5x minus 20. Change to multiplication, flip the last. Okay. The first fraction, 4x, can't be simplified. Denominator, 5x minus 20. It's a binomial. I'm automatically checking, is it a difference in perfect squares, or can I take out a GCF? I can take out a 5. So this would be x minus 4 then. Over on the right, I've got multiplies to 8, adds to negative 6, negative 4, negative 2. Denominator, not perfect squares. It is a difference, but all I can do is take out an x. So this is left with x minus 2. What can we divide out? X minus 2's, x minus 4's, And I have a 4x and then just an x in the denominator, so these x's will divide out. All I'm left with is the 4 in the numerator and the 5 in the denominator. And the last one. Keep, change, flip again. So I've got x minus 5 over x minus 7. Change to multiplication, flip the last. Right, now I'm going to do my factoring to see what I can divide out. So I've got x minus 5, x minus 7. In the numerator, I've got x squared minus 49. So remember, binomial, I'm thinking, is it a difference of perfect squares, or can I take out a GCF? This one happens to be a difference of perfect squares. What's a square root of 49? 7. So x plus 7, x minus 7. And the denominator multiplies to negative 35, adds to 2. That would be 7 and negative 5. So x plus 7, x minus 5. This is one big fraction. What can be divided out? X minus 5s, those divide out. X plus 7s, and the x minus 7s. If everything divides out, what happens? Now, some people will want to say, oh, well, it's 0. There's nothing left. But remember, what was 2 divided by 2? That's 1. Same on top, same on bottom. They divide out, but they divide out and become 1. So my final answer should be 1 here.